So in this lesson, we'll be covering the hyperbola, and we'll be going through the basics of sketching it, and really touching on also the line of symmetry, which is positive and negative. So really, this is the fundamentals of understanding how the hyperbola is sketched. So suppose you're given that f of x is equals to minus 3 over x minus 2 plus 1, and we're told we need to determine the asymptote of f of x. So we know that to determine the x asymptote, we know that we're going to equate denominator to 0, which will be x minus 2. X minus 2 is equals to 0, so we know that the x asymptote will be equals to 2. And the y asymptote, really, we just read it off with the sign in front of it, which will be y is equals to 1. Then we would have determined the two asymptotes. So if we go to the second question, question number 2, it says determine the x-intercept and the y-intercept. So to determine the x-intercept, we know that we equate y to 0 and we solve for x, and we'll be using really this equation throughout. So it means with this y, we substitute 0, then we'll have negative 3 x minus 2 plus 1, and then really we're solving for x, so we need to bring the 1 to the other side of the equation, which will be minus 1 is equals to minus 3 over x minus 2. So we know that any number is over 1. So what we can do now is to cross multiply, meaning that we have negative 3 times 1, and we're going to have negative 1 times x minus 2. So we can take this really and move our working here. So on the left hand side we have negative 3, and on the right hand side we have negative outside x minus 2. So negative 3 is equals to multiply in the bracket, which will be negative x. The negative will multiply the negative, which will give us positive 2. We can take the x to the left hand side, which will be positive x, which equals to, we bring the 3 to the right hand side, which will be 3 plus 2. Therefore x will be equals to 5. We can write it in coordinate form because we know that x is 5, and remember we had said y is equals to 0, so the y coordinate will be 0. So this will be the x-intercept, and we need to calculate what the y-intercept will be. So to calculate what the y-intercept is, we need to equate x to 0, and we solve for y using the very same equation. We'll have y is equals to minus 3 over, where there's x, we substitute 0, minus 2 plus 1, and we'll have minus 3 divided by 0 minus 2 will give us minus 2 plus 1. If you wish, you can just punch everything into the calculator to see what answer you get. So it's 1.5 plus 1, which will give us 5 over 2, or we can write it as 2,5. And we had said x is 0, so the x coordinate will be 0 and the y coordinates will be 2,5, and this will be a y-intercept. So far we calculated the x-intercept and we've calculated the y-intercept. And the next question, now we can move on to the next question, which says draw the graph of f by showing clearly the asymptotes and the intercepts with the axis. So the intercepts, they're referring to the x-intercepts and the y-intercept. So the important information here we calculated is, we know the asymptotes is x is equals to 2 and y is equals to 1, and we calculated that the x-intercept is 5 is to 0. It's the x, and the y-intercept is 0 is to 2.5. That's the y-intercept. So let's go ahead and try and sketch our graph. So we have to sketch this graph. So to sketch, we know that we need our vertical axis, which is the y-axis, and we need our horizontal axis, which is the x-axis, and really we'll be using this as reference. So you know that this is our y-axis, and we know that's our x-axis. And so we can start by sketching our asymptotes, which is x is equals to 2 and y is equals to 1. X is equals to 2. Let's suppose it's positive, so let's suppose x is equals to somewhere there. And we also have y is equals to 1, so it's positive, it's above the x-axis. Let's suppose it's somewhere there. I'm not drawing it to scale. So suppose this is 1, y is 1, and x is 2 over there. So we've sketched our asymptotes as the question asked. We sketched our asymptotes. Now we need to sketch our intercepts. Our intercepts, we have the x-intercept and the y-intercept. So let's sketch the x-intercept, which is 5:0, means it intersects where x is 5. Let's assume 5 is somewhere there, and our graph is obviously not to scale. And our y-intercept is 0 is to 2.5. 0 is to positive 2.5. It will be somewhere there. And we're given that the standard or the equation of f of x is given by -3 over x minus 2 plus 1. And remember, the standard form of the hyperbola is given by y is equals to a x minus p plus q, and we know that our a tells us the shape. So if a is positive, we know that our graph will be in quadrant 1, quadrant 3, and we know that if a is negative, we know that our graph will be in quadrant 2 and quadrant 4, and we can see that a is negative, so our graph needs to be quadrant 2, quadrant 4, and these quadrants are governed by the asymptote, meaning that our graph should be, so we had this will be quadrant 1, this will be quadrant 2, this will be quadrant 3, quadrant 4. So our graph should fall in quadrant 2 and in quadrant 4, and that's more or less really the graph of f. So you're going to get a mark for the intercepts, x and y, and you're going to get a mark for the asymptotes and also the shape of the graph. And it just depends on how they scale the question, but more or less you get marks for all those important points they mentioned in the question. So this is really question answered. This is question 3, not question 2. So that will be question 3. So the last question says determine the equation of the line of symmetry that has, oh, it omitted a positive. So what's the mission in this question? So that has a positive gradient. Or we can also make it a negative gradient if you want to, instead of saying positive, just to make it more spicier. We can say that has a negative gradient. What simply that means is that in any occasion, this graph has 2 axes of symmetries. By axis of symmetries, you mean a line that really can divide this graph diagonally in 2 equal parts. So one axis of symmetry would pass somewhere there, and the other axis of symmetry will would pass somewhere there, but I'll need to adjust this graph. It passes somewhere there, meaning that the yellow graph has the equation y is equals to, since it's an increasing graph, x plus c, and the green graph has the equation y is equals to negative x plus c. The important note that you need to take is that both these graphs intersect or pass the point where the two asymptotes meet, and that point is point 2:1, because x is 2 and y is 1 at that point. So that's the most important really takeaway you need to take from that. But going back to our question, the question asked us to find the equation, the line of symmetry that has a negative gradient. It means that we only exclusively be focusing on the line that passes that point. That's a decreasing graph. So this graph needs to be a decreasing graph. So as we said, this point it passes here, it's point 2:1. And we know the equation of this graph is y is equals to negative x plus c. So we have two things. That's equation 4. We know the equation of it is y is equals to negative x plus c. And it passes point 2:1. So we can calculate the c value. You know, that's x, that's y, means where there's y we substitute 1, where there's x we substitute 2 plus c. Should be 1 is equals to minus 2 plus c, which would be 1 plus 2 is equals to c. Therefore c will be equals to 3, and therefore the equation of the line of symmetry will be y is equals to negative x plus 3. And really we can also attempt finding the equation of the line of symmetry that has a positive gradient and see what equation it will be. But for this context, we would have answered the last question of this questions. So let's move on to the next part of the hyperbola. So let's label that question B. So we're given that sketch below is the graph of g of x. G of x is given by g of x is equals to a over x plus b plus q, and we're told that point A is 2:6 is on the graph. So point B is the intersection of the asymptotes. Okay, point B is the intersection of the asymptote. So we can see that B intersects is the intersection of the vertical and the horizontal asymptote. And we're told A is the point on the graph, and that's all. So we can actually see that point really coordinates of B are 3:4, because you can see the vertical is 3 and the horizontal is -4. So the coordinates of B are 3:4. And the first question really we can dive into is asking us write down the equation of the asymptotes of G. So the equation of the asymptotes of G really are based on point B, which is 3:4. We know that x will be equals to 3 and y will be equals to -4. That will be first part of the question. Question 1. Go to number 2. It says determine the equation of g of x. G of x is given by a over x plus p plus q. So we know what p and q are. P and q are nothing more than q. Your p is your x and your q is your y. So we can substitute that to the equation. We have a over x minus 3. We substitute an opposite sign here. And then for y, we keep the same sign as that. It should be -4. But now we don't know what a is. So we can just find a point on the graph that has both coordinates, and then we can use it. We can't use b because b does not lie on the graph, but we know that we're told that point A lies on the graph, so we can use point A to substitute to find the a in the equation. So point A has x and y, so it means where there's y, we're going to substitute minus 6 equals to a over x is 2 minus 3 minus 4. Now we're solving for a, we take the 4 to the other side of the equation. We have negative 6 plus 4 is equals to a over 2 minus 3 is negative 1, and then minus 6 plus 4 is minus 2 equals to negative a. Divide both sides by negative, it will give us a is equals to 2. But to answer the question, they asked us for the full equation, so we substitute our a back into the equation. Means our a will be 2 there, and then x minus 3 minus 4, and then that will be the equation of g of x. You get 4 marks for that, and you get marks for that. Now they're asking us to determine the domain and range of g. Domain and range of g. So when dealing with a hyperbola, domain and range is always the easiest. So the domain is x is an element of real numbers, but x cannot be equals to your x asymptote. When x asymptote is x is equals to 3, and your range will be y is an element of real numbers, and your y cannot be equals to y asymptote, which is negative 4. And it's always the same pattern. It's always x, domain is always x is an element of real numbers, but cannot be equals to x asymptote. And range is always y is an element of real numbers, but it cannot be equals to your y asymptote. And so far we've done the first question, second question, and the third question. Now we need to calculate, determine the equation of the axis of symmetry with a positive gradient. So axis of symmetry, positive gradient. So a line with the positive gradient and the axis of symmetry, we know that it will pass that point there. We know it will pass point B, right? Axis of symmetry. And we know that the axis of symmetry that has a positive gradient, the equation of it will be y is equals to positive x plus c. So we know what point B is. Point B is 3 is to negative 4. So it means we can go ahead and find this equation of the axis of symmetry. So on question number 4, the axis of symmetry is with a positive gradient is positive x plus c. We know that it passes point B, and point B is given by 3 is to negative 4. We know that we have x and y, so we substitute for y negative 4, and for x we substitute 3 plus c. So we solve for c, it will be negative 4 minus 3 is equals to c. Therefore c will be equals to negative 7, and therefore the equation of the axis of symmetry is x minus 7, and we will get our 4 marks. Then we move on to question number 5. Question number 5 says determine the equation of the axis of symmetry with a negative gradient. Okay, so now they're asking us a question where the gradient is now negative. So what do? As usual, we don't panic, we don't fret. We apply our knowledge, and we know that we'll pass the point where the asymptotes meet, the point B. But in this case, the gradient now, remember, is negative, so the equation of it will be y, the color is not visible, use red. Know that y will be equals to negative x plus c, and we know that it passes B as well, so we can go ahead and calculate this equation. So y negative x c, and we know it passes point B, which is 3 is 2 minus 4. B has coordinates y and x, so we can substitute it into the equation, which will be negative 4 equals to minus the x value is 3 plus c, which would be minus 4, is equals to negative 3 plus c, which would be negative 4. We take the 3 to the left hand side, plus 3 is equals to c. C is equals to negative 1, and the full equation will be y equals to negative x minus 1. And in that way, we would have answered question 5, and we would have gotten our full marks on our way to getting in A maths.